capable of flow is fluid. Then what is that differentiates between a gas and a fluid? Anything which is capable of flow is, we call it a fluid. Gas also can flow. Gas also can move. Then what is the difference between gas and a fluid? Right? Basically, by definition or by nature, gases are compressible. Right? Why? Normally the molecules are placed wide apart, so they are very light. They are compressible. In the sense, anything which has very less density, you can increase the density by compressing that. Right? Take the case of water. Water. 1000 kg per meter cube, right? 1000 kg per meter cube. What is the density of iron and of copper? It's approximately 8000 kg per meter cube. Iron or copper are solids. So we try to compare density of a liquid with that of water. What is a liquid? Okay. What is the specific gravity of mercury? 13 points. Let's say that 13,600 kg per meter cube. Right? So the advantage or the idea is those species which are already having higher density, you need to spend large amount of energy to increase the density beyond a certain value. So in that case, we normally treat water as incompressible. We always treat water as incompressible fluid. What do I mean by incompressible? You cannot increase the density. But that is not the case. Normally, you subject water to very high pressure. The thermal power plant now thermal power plant. Otherwise the steam, what is the pressure at which steam is getting generated in the boiler? It's approximately 160 bar. 160 bar, water goes inside, comes out as steam. So imagine how you raise the pressure of water to 160 bar. Whenever you open the tap, water comes out at very close to atmospheric pressure. Look at the force, because it comes out height of about 30-35 feet. Now I am having water at 160 bar. How can you raise the pressure of water to 160 bar? I said water is almost incompressible. Now I say it's again water. Concept of compressibility comes in. The very first thing is compressibility. What is bulk modulus? Then the Newton's law of viscosity, which I think you would have heard about that. Newton's law of viscosity. Here stress proportional to shear strain. Okay. Then you remove the focus on this side. What is the concept of proportionality you have? Coefficient of viscosity. Coefficient of absolute viscosity. Because there are two viscosity terms available. One is kinematic, one is absolute. Nu is absolute. What is the unit of viscosity? It's a very basic common term we need to model, but you understand. Kg per meter second, right? Kg per meter second, or 1 kg is kg meter per second squared is 1 Newton. So what is 1 kg? Right? You try to modify that and substitute minus of power minus 2 second per meter squared. Okay, this is a different thing. So what is coefficient of viscosity? Then what is density? What is specific weight? You heard of the term W is equal to rho g. What do you mean by W is equal to rho g? Or W is equal to rho g h sometimes. Is there any difference between mass density and weight density? Are they same? That is nothing but Euler, Gaussian, Bernoulli. Plenty of people who have studied many concepts in mechanical engineering or especially in thermodynamics, they all started with working in fluids. Sometimes you notice that small insects, they keep on moving in water. They can just walk in water, and we don't You have a rubberized string with inflated air inside, I can walk. I cannot directly just like that walk, is it? Why will I go? I get drowned, is it? The insect will not drown. Kuch ida, kuch alaga, cushion laga, why? What are the word surface tension? What are the word surface tension? What do you mean by surface tension? The name itself, right? Force or adhesive or adhering force which is acted upon by a small liquid, a small thin liquid figure, such that it can balance a small amount of weight. Bubble unless you try to press it for some time, it just remains floating. So now it just remains intact. How? Because of this surface tension. Okay. What I gave you is all examples of different things. Put all those things together. Many concepts. Okay. An important concept is this brake if you occur. This brake, how you this brake is getting activated. Right? Activated front brake, you have a small piston-like thing which pushes inside or which protrudes inside, right? Inside is a sealed chamber, allows the hydraulic fluid, brake fluid to move at high speeds because the tube is so narrow. Right? Height length, it goes down. So at that force presses the piston presses the brake pad, which is having contact with the rotor. An example of the physics of what is this? Ball algo, right? Nothing but Pascal's law. Try to press that, pressure or force is exerted equally in all directions. Same logic is used in your automobile brakes. Hydraulic brake, this brake, this is what happens. When it's a car or a two-wheeler, this is the right? So each and every concept is what we do in our, what we utilize or what we experience in our day-to-day life. Okay? So that is what is the significance of fluid. Right, that is to say that I'm not trying to concentrate each and everything. Slowly, different concept and go. AC room connectivity ಜಾಸ್ತಿ ಇದೆ, right? AC room connectivity ரொம்ப ಜಾಸ್ತಿ ಇದೆ. ಇದನ್ನ ಸುಮ್ಮನೆ ಕೇಳೋ ಅವರೇ let's take it. Total energy remains constant. Total energy remains constant is given by right? So the three forms of energy. Kinetic, potential and what are the thing there? What is rho gh? P plus rho gh above half rho v squared. That is called dynamic head. Half rho v squared or half rho c squared is called dynamic head. Okay? So this always remains constant for a incompressible flow. Right. Sometimes we notice when we try to water the garden, plants in the garden, the water is not flowing to extreme locations. As such, we cannot go that. A hose is very short. What we try to do? The entrance try to plug the finger and ensure that I get a larger stream or a stream which can travel longer. Is it not? Now what is that? Is what happens here. I reduce the area, my velocity will increase. Right? I reduce the area, velocity will increase. If I increase the area, what happens? Pressure will increase, velocity will decrease. That is what happens in your pump. Impeller runs at very high speed, so they have to push out water. Pump casing it is a slowly diverging system. Area consistently moves out or increases, so pressure will increase at the expense of kinetic energy. Kinetic energy will reduce, pressure increases, the pressure will increase. So that is what is the logic behind that. P plus half rho v square is equal to P2 plus half rho v square. Here density is considered constant, or rho 1 is equal to rho 2 is equal to rho. That is why I just mentioned that as rho, not rho 1 and rho 2. Laminar and turbulence. Okay, we have already studied that Reynolds number, it's a non-dimensional number, ratio of the inertial force to viscous force. When viscosity is very high, what happens? RE, Reynolds number is inertial force by viscous force. Viscous force is predominating, viscous force is very high. What happens to the value of Reynolds number? Denominator number ಜಾಸ್ತಿ ಆಯ್ತು, numerator எப்படி இருக்கும்? Should be less, so my Reynolds number is less. My Reynolds number is less. Automatically in a laminar flow, why the flow cannot have higher velocity? Because the viscosity of the fluid prevents. Na, 30 days and around 20 days and you won't know what days are. यार उन्हें जोड़ने हैं वो 360 degrees सुधर मारना है, ये मना रखा है. Okay, right. So under the influence of viscosity, the fluid layer cannot move in this fashion, but only in straight direction or in a uniform direction of, we call it, each and every layer are parallel to each other or tangential to each other. So we call that to be streamline. Any particle which is parallel to the direction of flow, it's called streamline. Right? So streamline the flow, no orderly flow. Why disorderly flow is not possible? Viscous stresses are the viscosities dominating the fluid flow, or it's more than the velocity, so it tries to restrict the velocity of the fluid. The Reynolds number is less for a laminar. Look at this. So you can see that there, after the cylinder, that is actually a cylinder in cross flow. Cylinder is side length half flow. Right? It's a famous problem in fluid mechanics. So that's nothing but cylinder in cross flow. Now, cylinder that happens, what happens? It's a turbulent mixing, or it's a very agitating type of fluid. So that is what you call turbulent flow. Yeah. Violence or what do you mean by violence? Suddenly it becomes too difficult to control. Right? Turbulent is something where fluid doesn't move in orderly direction. It moves in different directions, different velocities. So as I said, what happens? Velocity is much higher than viscosity effect. So Reynolds number is very high. That's the reason such a flow we call it turbulent flow. Say turbulent flow, the effect of viscosity is reduced or nullified. Inertial force, inertia is responsible for any motion. Inertial force is very high, the fluid moves with very high velocity. As a result, flow becomes turbulent. You take any flow, except this, you try to pour some honey. The bottle in the tail would bring a bit. Right? Why? It has a very high viscosity. It has a very high viscosity, because of which it cannot flow easily. Again, honey, the same flow. goes very fast. That is the so 99% of what we see on day-to-day life are all examples of turbulent. Examples of turbulent. Okay, and then of course you can classify them into two categories: internal flow through a pipe or a duct, or flow over bodies. External flow over bodies or internal flow through enclosure, duct, pipes, tubes, etc. I can see that there is nothing but the famous illustration used to describe the behavior of fluid. Right? I lighted a cigarette very close to the tip. I can see that up to this particular point, you can see that it is laminar because no change in direction. It's almost a straight line, smooth. Every layer is attached to that. Why it is attached? Because laminar I cannot divert. I don't have the energy to divert. The viscosity prevents me from moving in any direction, but only in straight line. But see, beyond that, it gets dispersed. It gets dispersed. So that is the difference between laminar and turbulent. Once again, that can travel 38 centimeters. Same shear stress versus shear strain curve. Normally we are studying for materials, ductile materials. Right? Ductile lana cable. Almost with a vertical line or a very flat line of 45 degrees. These are perfectly elastic, mostly mild steel. We are almost close to 45 degrees. The same with regard to fluid. Same with regard to a fluid. You can see that the middle portion is almost at 45 degrees, so that indicates that it is equally or it has equal reference to shear stress as well as shear strain. What about this? Any things which are fluids which are here? Small rate of shear strain, stress is very high. Or the small amount of stress or even a large amount of stress, strain is very less. Rate of shear strain, dou by dou will be very high. Whereas here, dou by dou will be very, very small, even for a very small shear stress. Okay? Accordingly, either we call it as become plastic or here tau zero, right? Tau zero, what do you mean by tau zero? There is no shear stress, or to say no viscosity. No viscosity. What is the fluid we call? There's no viscosity. Ideal. What is the other name for ideal fluid? Heard of the word inviscid fluid? Inviscid. 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 Any ideal fluid is called inviscid fluid. It doesn't have viscosity. Right? But any real fluid will have viscosity. You take any fluid, it has certain appreciable amount of viscosity. Right? It will have. So, always ideal fluids are having zero viscosity. Real fluids will have some viscosity. So, all your low viscous fluids all will come in the right hand side, bottom direction, whereas high viscous fluids, although they all go to the vertical line, the Bingham and plastic. Okay. What are the different fluids we can classify? Water, blood, honey, toothpaste, oil, okay. Oil, honey. To compare the viscosity of honey and toothpaste. What do you do? You try to measure what the force you are exerting in the tube, that will be very high. But for the force, because viscosity is very high, it comes out slowly. Right at the top, big gap on those things. Blood will be close to this dilatant. Dilatant and another one. What do you mean by dilatant? Why people they got the center, they easily get wrong. Why? Stress is coming as well, shear strain is very high. Here you are somewhere there, below the diameters. Right? Very small amount of stress, strain becomes very high. These are all important concepts. You can never get in any of the basic fluid mechanics guide. Fluid mechanics guide. Can anyone name the fluid mechanics guide for you? I have to advance again. I am talking basic guide. Okay. Definition mattada right? This is what I told you, surface tension, where insect, because of its low weight compared with the higher density of the fluid, it can easily float. That's how it can able to walk without any fuss through the water surface. Concept of pressure. What are the difference between stress and pressure? Local is stress. Huh? What is pressure? What is the unit of stress? Unit of pressure? What is the Pascal? Pascal और मीटर पर मिनट होने लगा क्या तो हो गया अगला प्रश्न है so stress unit is same, pressure unit is same, so why are we not saying stress, why only say pressure? Here also it is force per unit area, there also it is force per unit area. The logic is just the contingent being fluid stress we call it pressure. Whenever you have a force in the bounded area, right, we call it stress. Right? Assuming mostly solids are elastic in nature, the moment you release the load of force, area once again comes on the shape attains its normality. Clear? No such thing. It is always having permanent deformation. We call it pressure. We call it pressure. Unit is same, 1 Pascal or meter per minute square or whatever it is. But there is a permanent deformation. There will be always a permanent deformation. Okay? That is what we try to differentiate between stress and say stress acting on a solid bar, say stress acting on a fluid column or a fluid surface. Right? So this is. Then of course, I have 3 types of pressure: absolute, atmospheric, and gauge pressure. Always, air is having a pressure of 1.03 raised to 5 Newton per meter square or pascals, right? Being sea level. Clear? So, nothing is there. Even then, what's the pressure acting? Atmospheric pressure. What is the total pressure acting? Total pressure is always absolute. Absolute is total. You always add gauge pressure and atmospheric pressure. Atmospheric pressure is always there. Just like suppose daddy gives you 10 rupees, what the total amount you have? You say 15 rupees. Guy asks, how come you only 10? You always have 5 rupees with me. So the atmospheric pressure is like always I have a base or a data. To that you add what is visualized in the pressure gauge. Say it is 1 bar, the total pressure is or observed pressure is 2 bar. Right? Suppose the gauge shows 0.5 bar. Gauge shows 0.5 bar, it is below atmosphere. The absolute pressure is 1.003 bar and above, it is positive. If it is below that, I have negative. Right? We call it negative pressure as vacuum. We have negative pressure as vacuum. Simple. What do you mean by vacuum? Suppose, see, I try to blow some air. Air is present, so for me to blow, I should blow hard so that it can disperse. Suppose there is no resistance at all, what happens? Whatever the force I give, directly it's transformed into the acceleration of the fluid. Right? So no vacuum, no resistance, it can move. So we say vacuum is always below atmospheric or say complete vacuum. What is going to be a complete vacuum? You say that in terms of value. 0 millimeter of mercury. 760 millimeter of mercury is suppose say 0 millimeter. Ionization so no ionization. Low pressure is easily tends to ionize because the temperature is less. Pressure is also less. Easily tends to ionize. Same, right? 7 or 8 definitions: steady flow, uniform flow, unsteady flow, compressible flow, vortex flow. Right? The fluid properties or the parameters do not vary with respect to time. Even at any time, values remain constant. We call it steady. On the other hand, anything varies. Fluid parameters, velocity, pressure, whatever it is, we call it unsteady. What do you mean by uniform flow? Then what is the difference between steady and uniform? Uniform is fixed. At a given point, velocity always remains some value. It is called uniform flow. No changes. There is no change. Right? The parameters remain same throughout. Such a thing is called uniform flow. Such a thing is called uniform flow. What do you mean by a vortex flow? Vortex flow. Vortex flow. You experience vortex anywhere? Experience tornado, tornado. Nothing but the centrifugal action. High up, over and down. Rotation velocity will be very high. But at the center, it is a pivot or zero rotational velocity. Watch basically the area usually it goes slowly. But as the water level comes down, now it goes very fast. Trains very fast because of this action. It's a airfoil shape, right? Slightly of an airfoil shape. The aircraft wing is nothing but having the same section. Cross section except that slightly larger and wider. As you notice, how does the top surface compared with respect to the bottom surface? It's almost straight. Look at this. These are all streamlines. Every tends to just like hitting a speed breaker and then moving down. Hitting a speed breaker and moving down. Isn't it? So that is the reason air moving on top of this acceleration. What do you mean by acceleration? Increased velocity. Velocity increases, what happens to pressure? Pressure will increase. What about here? Flow goes undisturbed, so pressure will be relatively higher. Compared to this point. So low pressure, high pressure. What happens? We call that to be lift force. Right up, lift. Air with the layer of air moving past the top surface will be accelerated. Pressure come here, whereas the bottom portion goes undisturbed or relatively undisturbed. High pressure easily gets to this. Right? But will that happen at all conditions? Cycle நம்ம ஸ்டார்ட் ஸ்டார்ட் பண்ணுவோம் லைட்டா ஃபீல் பண்ணுவோம் புதுசா இருக்காம இருக்கு or if you are moving very fast, right? Road is smooth, it's almost down, you move very fast, you feel as if it is very light. Why? Flow of air past our body. So this lift will be there only at sufficiently high speed. Another airplane, for it to lift off, take off, should travel for about at least 1.5 kilometers at very high speeds. Bike racing ஒரு ஏர்ப்ளேன்ல ரேசிங் போயிருக்கீங்க யாராவது? பைக்கோட பைக்ல ரேசிங் ஒரு ஏர்ப்ளேன்ல ரேசிங் போயிருக்கீங்களா யாராவது? Yeah? Why? That moves easily at about 160-170 kilometers per hour. Now we can't feel the force because we got lifted. Mohan, Dr.M.R.SWAMINATHAN. We cannot achieve this. That's all the difference I told you. How we can study laminar turbulent flow? I have a small die, I allow some amount of fluid. Okay? As the fluid is very slow, die gets inserted, the color doesn't change. Layer by layer, I can easily see the different layers under normal colors. If I have increased speed, if I increase the speed of the water or the fluid flowing, what happens? Tends to absorb the dye just like anything, so as a result, what happens? It becomes turbulent in nature, right? Laminar, straight line, streamline. Transition effect. Localized as level, turbulent happens, level laminar happens, that is by transition. This is nothing but the y-axis is velocity. Look at the difference between this and this. Suppose today I take for the breakfast 2 idlis. Tomorrow morning 25 idlis. Third day 10 idlis. How will the cook for me? It will be very difficult because I am very much unpredictable. Right? Very difficult for me to predict because of such a unsymmetrical behavior or pattern. This is the reason as of today. Turbulent flow mathematical describe பண்றதுக்கு you don't have set of equations. You don't have set of equations. You have approximated that, but it's not actual. Approximate solution we have. Right? One of the entropy difference is our exact value of a turbulent flow is close to some value. It's not this value. I say close to this value. I don't say this is the value. Because how will I find out? How will I predict how the fluid will behave in the next few seconds? That is governed by laws of probability. Right? Turbulent flow behavior is governed by the law of probability. That process I cannot predict it. To some extent I can predict it. Maybe or may not be occurrence. That is the experiments. Right? I think after studying this, Reynolds experiment over there, Reynolds experiment. Take a small die, fluid moves slowly, the die doesn't get altered. Die slowly remains on the surface, moves past the surface. Inject die at fluid moving at very high speed, die gets mixed. It's a violent flow, so it becomes slow. That is the difference between laminar and absolute pressure is gauge plus atmospheric. Always I have the upper pressure as close to 1 bar. So the always absolute pressure is 1 plus what is the value mentioned in gauge. Normal for industry la value irukku bracket la G போடுவோம். Right? The theoretical people notice that they say something wrong. It's mentioned wrongly. Right? Invariably, it's understanding that it is a gauge pressure. Like the industry also it's always gauge pressure. Whenever they give a subscript G, indicates add 1 bar or add the atmospheric pressure to that to find the absolute pressure acting on the gas. That gauge and absolute. Gauge pressure shows 30 psi. Absolute pressure is 45 psi because 1 bar is equal to approximately 14.7 pounds per square inch. So, again, kilowatt. 25 psi, okay, pounds per square inch. Does it that 14.7 pounds per square inch is 1 bar. So, gauge shows 30 psi, absolute pressure is 30 plus 14.7 approximately 15, so 45 is the absolute. What about this? Express the pressure of minus 31 kilopascal as an absolute pressure. Gauge shows minus 31. Right? See that negative indicates below. Nothing has such a negative pressure. Anything below we call it negative pressure. Right? Anything below 0 or atmosphere we call it negative pressure. So that is how we need to reduce the pressure to find actual or the absolute pressure. Absolute pressure, but the actual pressure. So here, because it is vacuum below atmosphere, we need to subtract that. 1 kilopascal minus 31, which is approximately what's the value? 70 kilopascal. See, 70 kilopascal of 0.7 bar. So that is below atmosphere. I have said we are found or seen what is the pressure acting at about 12 meters below. So you know that P is equal to WH. Always remember this particular relation. P is equal to WH. And W is equal to W specified, W is equal to rho G. W is equal to rho G. That is the reason we get P is equal to rho G H. Okay. W is equal to specified. It is given by rho G. And P is nothing but W into H or rho G H. So see what the pressure is. Let's say what is 1000. Acceleration to 9.81. Height is 12 meters. 1.18 bar. 1.18 bar gauge. So the absolute pressure is 2 bar, close to 2 bar. Sometimes notice. Different people can go to different depth, but beyond a certain value, you cannot go. Why? Differential manometer. What do you mean by manometer? Manometer, we call it manometric head. Manometer is a mechanical instrument which can measure the pressure of a fluid in static condition. Right? Static condition. When air flows, right? How do you measure what is the pressure difference? Why air tends to flow? Suppose I pour water in a trap, inclined surface of the right. Why should water come down? Gravity. Basically, just undercut due to gravity to nullify the higher elevation it has. Then water we have a small inclination, we call it some drag. Similarly, in nature, always any fluid tries to nullify its pressure gradients. Tries to nullify its pressure gradients. So as a result, what happens? Sometimes we get air naturally, but there is no air flow. I need to create artificially what I try to do. Now in creating air, there is the fan. Fan in the north, just tries to create pressure difference from one direction to other such that air flows. That is what is the law. So we said manometer, a mechanical device used to instrument pressure. Sometimes we call it differential U-tube manometer. Differential U-tube manometer. What is that? I have a tube which is in shape of a laser tube. One will be connected to one fluid, say water or mercury. The other one will be exposed to atmosphere. Other one will be exposed to atmosphere. Fluid mechanics lab connecting the back. Whenever flow takes place in our lab, one trading, one limb will move up, one limb will move down. The one which exerts higher pressure, it will move down. One which is having exerted up, something exerts very low pressure, it is remaining at the top. So this difference in pressure is calculated in terms of, say, the water column or mercury. Then try to express in terms of CD root of 2GH. What is CD root of 2GH? Delta K is basically the CD root of 2GH multiplied by the correction factor. We call it, that is the discharge. U is equal to A into B. So, intermediate U is equal to A into B. It's basic relation. Padre university. Always. What is discharge of a ventilator always? A1 A0 or CD into root of 2GH by A1 square minus A0 square. The CD and root of 2GH is nothing but the difference in pressure. That is the reason the area changes, pressure changes. So by that I can calculate what the difference in pressure which I try to correlate for mass or the distance. kg per second or 20 kg per second. That is what is the actual. So, a manometer, differential tube manometer are different types. The pressure, that is that PA under pressure, atmospheric pressure same as now. Equally balanced. Suppose one is at a higher pressure, automatically tends to get depressed. level goes down. If I have no pressure on this side, it remains up. It's the same way. The fluid flows between two sections. Area is different. It's incompressible flow, so pressure changes, which is what we try to correlate in terms of discharge. Inner contractile orifice, area maradilla. The change we try to correlate or calibrate in terms of discharge or mass flow. Never we worry about what is the pressure at a particular point. If the point left, what is the pressure? We never worry about that. For us, ultimate is what is the pressure difference between any two given points. Delta P is important. We always worry about what is the delta P, difference in pressure between any two given points. Okay? Water column equivalent to atmospheric pressure. Height of water column equivalent to atmospheric pressure. Okay, atmospheric pressure how long? 1.03 10 raised to 5 Newton per meter square. P is equal to W into H. What is W? Specific weights. What is specific weight of water? W0G 1000 into 9.81 or 9810. 9810. 1.03 10 raised to 5 divided by 9810. 1.013 10 raised to 5 divided by 9810. What is the value? 10.30.
Was getting yeah. We know him.
So both product को check करो. मतलब क्या है? Let's discuss. Normal components जैसे कि sharp का जला. They are all basically centrifugal. Proportional distance is equal to WH. In exacted atmospheric pressure, water cannot take or lift water below a depth of 10.2 meters. 10.2 meters and 0.305 meter is 1 feet is 0.305 meters. So divide this 10.2 by 0.305, approximately 30 feet. Now, सारा काउंट करनी है ना हाइट 10.2 अब என்ன பண்ணுவோம் इधर यूज अ जेट पंप जेट पंप इजी will go up to 120 130 feet அப்படி இல்லனா compressor port. How does that compressor port get water? நம்ம compressor then என்ன அவுட் வரும் air உள்ள போறது வெளிய வந்து வாட்டர் ஆச்சரியம் இதுவா उल्ला कार जोड़ने वेली वर्मो तन्ने है what happening deep down compressed air tends to push up because it has high pressure close to 10 bar pressure level goes down to the hose and tन्ने को तन्ने करीला so tends to push up water through the hose ना compressor बढ़िया बोलने में तन्ने बात नहीं ना it's not continuous बिट्टू some air column water column that's the logic அதனால உங்களுக்கு ரொம்ப 250 feet ல போச்சு அப்படினு சொன்னா 250 feet jet will try to suck water but the problem is jet எப்படினா boiler right 10 tube வர ஒரே நிமிஷத்துல காலி பண்ணும் okay but when you go below that much deep, you don't have flow continuously. Adhe thanni irukadu. Adha use jet what happens? One thanni zero. So that is the reason I don't want continuous supply, or I will not have continuous supply because depth is so high. I don't have continuous water supply, copious water supply. I use only bore which tends to intermittently suck up water. Right? Other way, I don't tell you. Plenty of water is available and use it. Depth in an arm, very high discharge. High pressure, high discharge. That is centrifugal problem of low pressure and low discharge. We want low pressure and high discharge, low pressure and high discharge, and two centrifugal pumps parallel. So that same pressure is like two people doing the job. High pressure, high discharge. That's the reason we are using compressor bore where you don't need compressor bore. You don't have copious large amount of water supply. Source is limited. So if you try to suck up using a jet pump, jet and a global. Don't get water. Concept of boundary layer. Boundary layer. What do you mean by boundary layer? Separates the system and surroundings. Ball was the ball here. Billiards ball. Okay, hand over the difference. Size no same super size. All way material same. But what is the ball? Specialty ball. Ball data. Ball pan data billiards. Dimples, okay. It's called dimple, right? Depression on the surface. Okay. Why? Why can't we have the same geometry of a billiards ball for a golf ball? Golf ball and billiards ball right? Complete sphere without any depressions on the surface. First understand the concept of viscosity, strokes drag. Terminal velocity of the failure becomes terminal velocity. Suppose we are dropped from the plane at a height of about say 500 meters. And you speed in this plane right? So we come down. Force height that is both jasty so as and when time lapses we come down with the greater force. It's jasty right? But after some time what happens is that when I move fast, what happens? Air tends to stop the decelerating. After a certain time my entire weight is balanced by the air resistance. That happens afterwards. I always move the constant speed. It's called that force is called Stokes drag. Right? Force is called Stokes drag. Force is called Stokes drag. Depends on weight. Weight come here quickly or in Stokes drag. Weight just here you travel faster before which the balance on your weight is balanced by the gravitational drag of the air. Afterwards, you move down at constant velocity. Stroke resistance. Okay. The logic is, the moment I hit the golf ball, right? Before it experiences boundary layer effect. Once it experiences boundary layer effect, it will slow down and then stop. Ultimately, it comes to opposite direction. So, if I try to ensure that the boundary layer effect or the boundary layer surface build up is delayed. Like from service air la ponalo 20% and layer for the slow item tension stop. So if I try to delay that, because it was between traveling in air for about only few seconds, 8 to 15 seconds it travels. After that it should come. So if I try to delay the building up of only layer, I can ensure that it can travel long distance. Only layer I have to only breathe out and out, long distance again. So that dimples on the ball of ball. So nothing to that. They try to delay the boundary layer separation because on top of that, right now, surface smooth on the top of right? So boundary layer gets separated, so ball cannot travel fast. But on the surface of this ball have dimples. Surface only even have. So it is not, cannot sit, air cannot sit on top of that, so it can only float near that. Then, the same logic here, the boundary layer separation is delayed, which results in the ball traveling longer distances before it starts to run. The boundary layer separation is delayed boundary layer separation. What is the reason for this difference in the what is the sometimes even the helmet level is black and white helmet. See, for example, and move past that, the stop black resistance, so higher fuel consumption or more fuel consumption, so ultimately this is the emission fuel. Logic behind this boundary layer. So boundary layer application always no slip condition. What do you mean by no slip condition? No slip condition is the water layer next to the pipe surface is foam layer. What's the velocity at the wall? All velocity of the wall and velocity? Zero. Because friction, of course, two things. One, friction between the layers, we call it fluid friction, which is viscosity. Then, solid or wall friction. Solid or wall friction. Anyway, the ideal fluid can have water there, ideal fluid acid can have slip condition because no viscosity can easily move past. No loss. Okay? This is a very important topic of no slip condition. It has certain viscosity, cannot slip past the wall. Experiences. So, as a result, what happens? Velocity at the wall is no fluid is moving past the wall. Now, the velocity is zero at the wall, maximum at the center. Away from farthest point, away from the wall, I have maximum velocity. Which is the farthest point away from the wall? Center. Wall at the maximum, symmetrical at the axis. Center. So that is I have maximum velocity in the center. That is the velocity distribution for a laminar flow. Right now, what is that? That is the important concepts. Velocity distribution and shear stress distribution are two important things we will discuss about pipe. Velocity distribution and shear stress distribution. Okay. Good question for that. All questions. Can you say what is a fully developed flow? What is a fully developed flow? Fully developed flow. Okay, say this is measured at say pipe or length of the 50 feet. Say when they measure at a particular point, this is the variation in velocity. Yeah, stabilized item, viscosity constant item, losses stabilized item. That's how the profile. This is a velocity profile or a laminar You always understand the continuity equation. Whenever any fluid flows through a pipe, fluid or gas or whatever it is, mass flow rate remains constant. First of all, mass flow rate na m dot kg per second. Repair mass flow rate to discharge condition. Discharge na, if you say discharge is always volumetric flow rate. Volumetric volume na volume. LPH. What is the unit of volume? Say volumetric discharge meter cube per second or meter cube per minute. Clear? For this case, volume will be different because area is different, but mass flow rate remains constant. Section 1 liyo, section 2 liyo check padi padinga. Volume different. Mass flow rate same ata. Now, mass flow rate is governed by continuity equation. Product of rho into A into C is equal to constant. Product of rho into A into C is equal to constant. Keeping density constant, area increases, velocity decreases. Keeping density constant, area increases, velocity decreases. Velocity increases, area decreases. So, mass flow rate remains constant, density discharge unit per second will change. Kg per second remains as it is. Is always unsteady. Is always unsteady. Unsteady, not consistent unsteady. Right? Aperiodic unsteady. Never can judge or try to study the chemistry.